Commutative property and associative property. Before we do this first example here, it actually has not much to do with it, but yeah, I guess it does. Commutative. What's the root word of commutative? Commute, isn't it? Right? What does it mean to commute? Move, go place to place, travel, right? And associative property. The root would be associate, right? Like to gather with different people in different ways, maybe, right? Okay, yeah. So keep that in mind. Let's just take a look at this example here. Who wants to add this without a calculator? In order of operations doesn't really, I mean, you should be going left or right, but since it's all addition, it doesn't really matter, right? So that's kind of hard to keep track and do that in your head as you go. So let's kind of, yeah. Say again? I think it comes to that. You just do that in your head? All right. Well, I think it comes to 40. Yeah, it comes to 40. How about that? All right, if anybody needs a calculator, use her. Okay. You might be able to take her home with you if you don't have a calculator at home, maybe. So let's take these like a couple at a time. Let's kind of group these two and then these two and then those and those. All right? So let's associate those. What's 3 plus 9? Plus what? These two. 6 plus 9, 14. Now let's just kind of group those two and those two. What do we get? 18 plus, what is it? 22. And now that's pretty easy to do in your head. There's where we get 40, right? I don't know if you put it together in your head like that. Maybe different, but yeah, that's one way you can do it. Okay? So what we did is we kind of reassociated. We kind of grouped certain things together. And that brings us to our properties. Alright? So the first one, we have commutative property. We have it for addition and multiplication. Okay? And it does not apply to subtraction and division. I'll get to that in a minute. In fact, technically, mathematics, especially if somebody's go on to college and takes college math classes, there technically is no such thing in math as subtraction or division. Yeah, right, yeah, no, I agree. There is, for all practical purposes, you need to be able to subtract things and divide things, right? But to stay consistent with certain properties in mathematics, there's another way to think. I'll get to that. So the commutative property, right? Commutative, commute. What does that mean? It means to what? Move or travel, right? Oh, look at that. See? It's glitching out on me. Okay? So we could rearrange things, especially if we're just adding two numbers. 8 plus 4. If I was to move or commute the 8 and 4, what would that be equivalent to? 4 plus 8. And even though I switch the order, they both equal 12. Okay? So it applies to addition. Okay? So this is the commutative property of addition. Same with multiplication. 6 times 3, if I move the numbers around, will be the same as what? There we go. Oh, I know why. And they will both be equal and multiply to 18. Okay, so that's the commutative property of addition and the commutative property of multiplication. If you're ever asked to identify like which property was used, right, you can't just say commutative property. You got to say whether it was for addition or multiplication. Okay, be aware of that. Now the associative property, right? It's like having your free associative one of your life, right? You can move to let's say you're out in the cafeteria, right? Let's say there's 100 kids in the cafeteria, I don't know, right? And some number of kids per table, right? And you get up for one table and go sit and associate yourself with a group at another table. Still the same number of kids in the cafeteria? Yeah, even though, you know, we added you up and you're in a different place, you still get added in, right? That makes sense? Okay, so you can read. So usually with the associative, you'll see it played out with parentheses, grouping things. So parentheses, kind of like your lunch table or something like that, right? So 3 plus 5 plus 9, see how they have the 3 and the 5 are together here? Well, I could also write that as 3 plus 5 plus 9, like that, right? Wouldn't they be equal? Right? Just move to a different table in the cafeteria. Or, by the way, like that. Same with it, yeah. So they come all the tables except one, and you all got to sit together. Yeah. Just grouping them, associating them. And it's like the lunch table, right? You move to a different table. And so both of them add up to what? 17. Let's look at it with multiplication. Same thing, right? 2 times 5 times 7 will be equivalent to 2 times this group, right? Or, I know this seems, fairly obvious, but these are like super simple examples to illustrate the point. And all of these, both, in all three cases here, multiply, so what, just 10 times 70, right? Okay? Now, I mentioned that before we go on, that we cannot apply this to subtraction or division. So I want to give you a note, like I did yesterday. So jot this down here. All right, and when you go back and look at your notes and you see that, it means to go to that blank notes page. So we're on page 19, okay? You see this? Go to page 19. It says notes. Okay? This is what I want to add in here. These properties do not work for subtraction or division. Okay? Properties do not hold for subtraction or division. I'll give you a couple of examples here. So let's try the commutative property. Well, 5 minus 3 give you the same result as 3 minus 5. Okay? What is 5 minus 3? And then 3 minus 5 is, right, so I'm going to put not equals for each of these, right? So do you see how these don't work with subtraction? Okay? Let's try division. How about 10 divided by 5? Is that the same as 5 divided by 10? What's 10 divided by 5? And what is 5 divided by 10? What is it? 5, like 5 over 10. It would be 1/2, wouldn't it? And 2 does not equal 1/2. So you see it doesn't work with division. But, since you only work with addition and multiplication, what would be another way, though, of thinking about subtraction? Yeah. So now we're using addition. What about it? What about negative numbers? You mean add? We could think of subtraction as adding negatives, couldn't we? Right? So think of subtraction as adding negatives, adding a negative. Think of subtraction as adding. So now we're, right, adding is now in the realm of where these properties hold. Adding a negative. And division we can think of as what? Well, not always 1/2, but you're on it. And division as multiplying by, think of it this way. Let's say I wanted to take 8 divided by 2. What's another way to say 8 divided by 2, but using multiplication? 8 times what? Go ahead, 1/2. Now you're multiplying by 1/2, right? So think of the multiplying as dividing by a fraction. Or no, think of division as multiplying by a fraction or a reciprocal. Okay? Let's try our example up here. Okay? Instead of 5 minus 3, I could write it as 5 plus what? Okay? And now, by the way, guys, don't ever write 5 plus minus 3 without parentheses in there. Okay? I mean, I think you've been gotten away with that for a while. More. Okay, remember, algebra is a language, very specific and efficient language, and I think you should probably get a foreign language credit for taking this class. And as such, I'm a grammar Nazi, okay? Especially when it comes to the languages like that. Right? So, would that be the same then? Now, if we switch them around, now does that commutative property hold? So 5 plus negative 3 is 2, and this also is 2, see? Okay? Let's try the division. Okay? So this was our 5 minus 3, right? What was the other one? 10 divided by. Let's try our 10 divided by 5. Okay. So instead of saying 10 divided by 5, could I say 10 times what? 1/5, right? 1/5. Now I'm multiplying, and now the property should hold if I switch them, right? So now this should also be the same. What's 10 times 1/5? 2. 1/5 times 10. Okay? So you see how we can convert subtraction and multiplication, or subtraction and division into addition and multiplication to stay consistent with our properties. Now, we'll say, again, in every practical sense, go ahead and use subtraction as you always have, but you just need to know the distinction here, okay? All right, does everybody have this? Let's go back. Yes, this here. Page 18. Example 3, actually, example 3 is kind of like what we just did. Here's an example that shows subtraction is not commutative. How about just 8 minus 4 not equaling 4 minus 8? Everybody agree? Because we just did that. I just did it. All right, just pick one random. I should write that as 8 plus negative 4, and then it will work, right? Okay. Example 4. This is change function expression involving addition subtraction into one only involving addition. I think we kind of get how to do that now, maybe. And then use the commutative and associative properties. Okay? All right, so let's do this. Let's rewrite this. Equals, instead of 7 minus 3, it'd be 7 plus what? Come on, everybody. Negative, you guys got to speak up. All right? Plus 8 plus what? Negative 2. Plus what? Negative 6. Plus 1. Careful now. Plus what? The negative of a negative is a positive. Yeah. So it goes together, right? Okay. Now let's use the commutative and associative property together. Okay. Let me move all the positive numbers and group them and associate them, and then all the negatives. So let's do this. So I can do like 7 plus 8 plus 1 plus 3. Okay. Now, let's get all the negatives together. Negative 3, I'm going to just have to nest the parentheses here, right? Plus what? Negative 2 plus negative 6. You got parentheses, one parentheses, right? Nest. Okay, we'll simplify this where we've associated them here. All right, I'll go up here at the top. Equals 7 plus 8 plus 1 plus 3 is 19. Plus what? -2. Negative what? Plus -11, right? So that's your 19 minus 11, which is what? 8. All right, kind of get the idea here? Like a lot of the stuff we're doing right here, you know, as we move on, you're not going to really have to present it this way, but this is just so you understand how these properties in math work right now, okay? All right, let's go down here and apply that to, well, quick review of combining like terms. Remember combining like terms? Like terms are terms that have the same variable with the same exponent, right? Okay? So, there's 5x and 2x. Are they like terms? Okay, they both have an exponent of 1 on the x, don't they? We don't have to write it, but we know it's x to the first, right? Okay. Well, let's combine them. What do you get? 7x. Okay, next one over. 7x plus -3x. They're like terms. What does that give us? 4x. Now the last one, -8 plus -2x. -10x. Right? Okay, simple enough. We'll review some like terms. All right, let's go down here. So they've gone through and done the arithmetic. They just want it to name which property. Okay? So, what have they done from here to here? From this group, 3x plus 7 plus 2x plus 8, over to here. What property allowed them to just drop the parentheses and just reassociate all of them? The associative property, right? So this is the associative property now of what? Addition or multiplication? Addition, right? You got to have that in there, right? You got when you answer this, and we can abbreviate. Shall I abbreviate? Abbreviating. Math is an efficient language. What? Abbreviation confuse you? Who put division? I said division? No, I did one. Associative property multiplication. Huh. How about that? Sure it was me? Somebody that looks like me. Okay. All right, anywho. Wait a minute. Okay. Okay, so in the next step, they started with this, 3x plus 7 plus 2x plus 8 equals 3x plus 2x plus 7 plus 8. They move things around with property. Moves things. Commutative property of what? Oh, I get what you said. I thought you said I said division. I get it now. Addition. Associative property of addition in the top one. And I wrote multi. And I thought you said that I said division. Okay, so now that we back up and I'm clear as to what you said, just hang on. All right, hang on. Hey, guys, wouldn't this be why I insist that you do math and pencil, right? Addition. Okay. And the second one is the commutative property of addition. And the last one, they just took this and regrouped these things, didn't move anything, so what is that? There we go. Associative property, and these are all addition as it turns out. I don't know why this kid's trying to tell me multiplication. I understand that. It makes sense to me. See if you can figure them out. Okay? I'm just turn it over.
Oh, four.
Oh. Okay. So down here, they want us to combine the expressions below. And they want us to do the thing of replace subtraction by adding of negatives, okay? So let me go through the first one with you. So let's regroup. Let's use the commutative property and get all the x's together and all the other terms, right? So 4x plus the negative 2x, and then just plus 6 plus what? Negative 9. With me? Okay. And again, I'm not going to need you to do this for too much longer after this section, okay? This is just to illustrate. Okay, let's combine our like terms. 4x plus negative 2x is 2x. 6 plus negative 9 is? Okay, can we combine these two terms? 2 minus 3, why not? Right, they are not like terms, right? You know, technically it does. You don't have to write this down. Technically, this is 3x to the 0 power, and that's 2x to the first. Maybe you know anything to the 0 power is 1. So just as a matter of being consistent. Right? But anyway, I don't want to just... Okay, so I worked you through this one. I want you guys to try B and C here on your own. So make it look like I do with the equal signs connecting everything, okay? Regroup any x terms, okay? Write any subtraction as adding the negative, okay? So I want to take a second and do part B and see what you come up with. Everybody get a final answer here? Just say it.
4x plus 12.
She says 4x plus 12. You guys agree or disagree? Yeah, it's 4x plus 12. Good. 4x plus 12. Okay. Move on to part C. Be careful, you'll have to replace some of the subtracting with the adding of a negative, okay? Just shout it out. Just say it. I'm there you go look at it.
3y plus negative 13.
3y plus negative 13?
Yes, negative.
Would it be negative 3y?
Yes.
Negative 3, ultimately it'd be negative 3y minus 13, right? If we handle switching it back, right? So you get like 4y plus negative 7y, you did this part, right? Plus negative 10 plus negative 3, right? This annoying stuff that we want to do for much longer. So that gave us your negative 3y plus negative 13, which of course is negative 3y minus 13. Okay? Any questions on commutative or associative properties of addition and multiplication? Okay.